Hello and welcome to our second video about classes for beginners. And in this second video we will continue developing the class. And this is where we left last time, that we have this program which is able to count how many times we have modified this smart integer here. And I have a picture about this situation here. So this is the situation we have here. So the integer h John is here, so it's just the one variable here, and here is the h Peter, the smart integer object. We can think this as a box. So this box represents this object, and inside this box we have this value. So when we say h Peter, it's not this value. The value must be accessed from the inside of the h Peter. So h Peter contains this value. That's why they call, actually in programming, they call it as a container. So this is the container which contains this integer variable. And here we have this integer variable on itself. There is no container here. So let's continue now. I think I will take out this integer now, and let's see a little bit more about this smart integer. And that's Peter, so I can take out this one. Oops. Can take out this one, and also this one. Also, I will take out this modify count, because this is not really a useful thing. Why would we count that how many times we have modified? So I will take it out. We don't really need it in real life. So we have a very simple class now at the moment. So what we can do here is that we can create another smart integer type object. Let's call it John, and here we can set this John set value, and we can put 34, and we can do the same thing here. I'm just trying to show that these are two different objects and they have different values in them. So this will print now like before, but we are now using only the objects, two different objects. So this is the Peter object and this is the John object, and they both are smart. They both have a smart integer type. So if we run this program now, we will get like this, 74 and 34, right? So, and obviously we can create as many we want these things. Here we can create more and more H, Jim, and so on. What we also can do, obviously we can do anything with this one, basically almost anything than we can do with normal integers. For example, we can create an array, humans, 10 items, so 10 humans now. So in this case we can call each of the human, we can call the same way. So human, the first human, set value, and then I just got updates from Windows. But let's continue. So we can set value 33, and then we can set the value for the next human in this array like this, and then we can obviously print them the same way. There's no difference really with this one and with the normal integer array if we created an integer humans like this. It works exactly the same way. So okay, let's take out this one now, and let's go further now and add something to this class. So put this back here. It's John. Okay. So what would we add next? Let's next add a operator, because one thing is missing here at the moment. Let's say that we have a normal hgym, and this hgym we can set this value like this. Hgym is 46, like this, and it all works there. It compiles and everything, obviously. And oh, there was some, what is this mistake? It's gym redefinition. Because I happen to have exactly the same name. So now, so this is all good, but actually what we want here, because this is also an integer, we see this one as an integer. It's just a smart integer. It's the integer we created, but we would really like it to work like this. Am I right? So what I would really like here, I don't want to say set value 74, because this is too complicated here. What I really would like here, I would like, instead of set value 74, I would like to do like this. The same way. I would like to do the same thing here, here, than we are doing here. But there is a compilation error here, obviously, because what we are trying to do here, we are trying to set this container to 74, not this value. So there's a big difference here. We are trying to set this container, this one, this box, this outside box, kind of. We are trying to set this outside box to 74 and not this value. That's the problem here, and that's why it's complaining that you can't set the box to 74, because the box is not an integer. This is an smart integer object, but it's not the same thing as this integer. This integer is inside that object. Okay, that's the problem here. So, but is it possible to do like this? Well, it is. Fortunately, it is. C++ has nice way to do that, and I will do it next. It's called operator overloading. We can overload this equals operator inside this class, so that we can do whatever we want to do. When we type this one against this object, we can, and we have an integer here, we can decide whatever we want to do for this object, and we define it here. We can even print something. It's up to us. So operator, and then so this is a special C++ keyword operator. As we can see, it's a blue, meaning that it's a language specific keyword. And next we define which operator we want to overload, which operator we want to define ourselves. So we want to define this operator for this for all of these objects created from this class, meaning that when we use this one, we are just now defining what it's gonna do. And next we're gonna put the brackets, and inside the brackets we will put the right hand side variable and its type. So this type needs to match with this one. So if we want to have an integer on the right hand side, we need to put here integer. So this type needs to match with this one. So we want, in this case, we want to do an integer assignment. So we put integer, and then we put here, let's say new value. So now this is exactly gonna do basically same thing as this set value, but it's just a nicer way to do it. The final result will be the same, that we are setting this private variable to the new value. And the implementation here, it will be exactly the same like here, no difference. And we need to have a return value. So let's for now return nothing. So this doesn't return anything. This void means that function is not returning anything. So now, as we can see, it compiles there is no red line anymore, and if I press compile, everything succeeded. And now it's interesting to see, let's see if this really works. So I will take out now these two things so they don't confuse us, and now let's test this one. So let's see if Peter is now 74. Okay, and Peter is 74, so it really did go there, and it did do that. Okay, very good. But that's not all. That's not all. We can go further than that. We can. What if we have here? Let's say that we have here, for example, a. Let's say that we want to set John's age, for example, to 86.8. Okay. Now, what normally happens if we put a float, if it happens to be that somebody is assigning a float or decimal number here, so what would we like to do here? Well, it's very likely that we would like to round it. We would like to round it, for example, this one in mathematics, this would be rounded up, so this would be 87, and this would be 86. So it rounds to the nearest whole number. That's what we might really like here. That because if let's say that if it's like this, so if we assign this number at the moment to a normal integer, it just cuts the decimals, and it doesn't always make sense because we probably want this one to go to 87 in many cases if we are forcing it to an integer. Okay, but we can do that actually. Now this smart integer can do this roundup. This one doesn't work. If we run this gym now, let me show first that it's the case. Let's print gym here. I will put this one into comment. So let's see gym. Okay. So the value of gym is 86. So as we can see, it cut all the decimals out. But we don't necessarily want this behavior, so maybe this smart integer can do better than that. Maybe we can create a function here which automatically rounds it correctly. And yes, we can. Let's do that. Let's just overload this operator again, but now with a different type. So this is a double. So I will just write here double. So now whenever on the right hand side we have a double number, it will choose this implementation, not this implementation. So it always chooses the closest one. But this one here chooses this function because integer is closest to this one. It is actually exactly this is exactly integer, and this is exactly double at the moment. So they all go perfectly to these functions. Okay, but here we don't want to set this one because this would cut decimals again, because this is an integer and this is a double, so there would be no difference now. So what we can do here, we can call a function called round. C++ library has this nice function called round, which is doing the mathematical rounding, exactly like in maths we do. So it rounds to the closest whole number. So let's see now if this one works. Yeah, everything should be fine. Let's say it's 74.98. So if this thing works here, we should get Peter's age 75 now. So let's run this. And we can see that it is 75. And that's good. So now we have overloaded two types here. We can go further. We can overload another one. We can overload, for example, a string, even string. Okay, so in the case of string, we need to turn string to integer. Stoi is means string to integer. So if this is a string, we can convert string to an integer using this library function. To be able to use that, we need to include string here. Okay, and now it works. So what we can do now is that we can say let's use this Peter again. We can say Peter. We can use a string here now. Let's put 74. And if we run this now, it will still work. And there we go. The age is 74. So we're using different types. This is a string. This has nothing to do with the number, this one. This is like John, Peter, or London. We can write here London here. Okay, so this is quite cool. So this is really a smart integer now. It can take in all kind of types and nicely convert them always to the correct one. And we can even go smarter than that. What about this? Let's say that we want to set 1 or 2. Let's say 4. What if you want this one work? So this is the smart integer here, and we want the smart integer work so that if somebody types 4 string, it will contain value 4 after that. How would we do that? Well, we already have this string operator here. This equal operator is overloaded here, so we can just add it here. It's not that difficult really. So because this is a string, it will go here. I will take out this one. Okay, again, because this is a string, it will choose this implementation here. And now here we can do an if statement. We can say if this value, if this string value is 4, in that case we will set this integer to be, and now how do I do this again? I do this okay, now I have done this before. Where did I put that? I have to check how I did this. I did this before here. How did I do this? Just a second. Numbers 1. Aha, okay, I did it like that. No, so sorry. This is very simple. What am I doing? What am I doing? If the string is 4, then of course we put here 4. Simple as that. We don't need to convert anything. We just put 4. And then we need to put here else. If it's not 4, then do the normal stuff. Then it's probably like this, and then this one takes care of that. But if it's a 4, which is a special case, then it will go here and set this integer value to 4. Let's test this now. So if I put here 4 and we run this, and there we go, nicely working. There is Peter's age is 4. Age Peter 4. And this is an integer 4, by the way. And I can prove it. We can say here that print this value plus 9. If this is an integer, we should get here 4 plus 9, which is 13. 13. And I will prove that now. There we go. Peter's age is 13. 9 plus the current value of Peter's age. And obviously we can easily add here as many of these as we want. Obviously we could add here 1. Using the same logic, we could add 1 and say the value is 1. else if, let's put one more here, like that. We can say if it's 1 or if it's 2, then set it to 2, like this. Okay, let's test this now. So if the user types 1 here, it goes here and it sets the integer value to 1. And if types 2, and let's run this now one more time. I put 2 here, for example, and let's run it. And we get 11. It's because this is 2. We get 2 plus 9, which is 11, and that's why we get this 11 here. So it all works nicely. Very good, very good. And I think we can finish this one. And one thing is that I will be creating another class example. We will soon finish up with the smart integer, and I will create another class soon, and we can start playing with that. I don't know, maybe a dog or cat, or I will think about that. But let's have another example and start from the scratch again and do some things there. Okay, thank you very much for watching, and see you in the next video. Bye bye.